Hey guys, this video is going to talk about angles in standard form. So this is the second video in our unit 12. So what we're going to be talking about is looking at angles on a coordinate plane here. So any angle on the coordinate plane is in standard form when the vertex of the angle is on the origin. So here would be the vertex right there. And then we're going to have two different rays, okay? The ray that's on the x-axis right here, let me pick a different color. This is what we call the initial side. That's like where the angle starts. And then the other ray is what we call the terminal side. And this is kind of where that angle ends. So this little swoop that you see here is kind of showing what we did to create this angle. Now, counterclockwise rotations are going to result in positive angle measurements, and clockwise rotations are going to result in negative angle measurements. So the one that you see on the screen here, this would be a positive angle measurement because we moved counterclockwise. And then you all know that if we make one full rotation, or one full revolution I should say, that's going to be a total of 360 degrees. So notice each axis is labeled here with some degree measurements. 0, if I went all the way around, this would also be my 360 degree mark. So let's just draw a couple angles here. Okay, remember that we should have the initial side on that positive x-axis. Okay, the vertex of my angle should be on the origin. And then if I have a 75-degree angle, remember that up here was 90, so we're not quite making it there. Now, since it's positive, we're going counterclockwise, so I'm going to draw that arrow here, and that's a 75-ish. You know, it's not going to be perfect. This is just a rough sketch, but that's a sketch of that angle, 75 degrees. Now, 160 degrees, but this time negative, means that we're going to be still having our initial side here, but now we're going to be moving counterclockwise. So this would be like negative 90 degrees, negative 180 degrees. So negative 160 is a little bit less than that. And again, let's use that arrow to show the direction that we went. So that'd be about negative 160. Now, 430 means that we actually go around one full time and then some. So we're going to go around one full time, that's 360. Okay, so we need to think how much further we're going to get from 360 to 430. Well, that would be 70 more degrees, so it's going to end up about here. Now, that doesn't look much different than the 75-degree angle over here, and that's because the angle really, there's not much of a difference on that coordinate plane. You wouldn't really know that this was 430 degrees if you didn't have that spiral in the middle showing you it. So it's really not that important for our purposes. There's not going to really be a difference between a 430 or a 70-degree angle, and that's going to have a name to it that we're going to look at here in a little while. So I want to talk about radians. Radians are just a different unit of measurement for angles, and we are much more comfortable with degrees, but we can convert back and forth between degrees and radians. Just like I'm sure all the time in science, you're converting between feet and meters, miles, kilometers, minutes to seconds, things like that. It's really just dimensional analysis if you think about it. So there are 180 degrees in pi radians, okay, or 360 degrees in 2 pi radians. So we have a little conversion here. If I have an answer in degrees and I want to get it into radians, I'm going to multiply my degree measurement by pi over 180. And if I have an answer in radians that I want to convert to degrees, I'm going to multiply by 180 over pi. So let's just see what that would look like here. Okay, I've got 150 degrees and I want to convert it to radians. I'm going to multiply by pi over 180. Okay, and think about it like this. The degrees are on top and on the bottom, so that unit would cancel out, leaving us with radians. So really, I just need to reduce this fraction here. Okay, 150 over 180 would reduce to 5 over 6. So this is really just 5 over 6 pi. Or you could write it as 5 pi over 6. Okay, let's look at another one. Okay, 30 degrees. I'm going to multiply by pi over 180 degrees. Okay, and remember, we're really just reducing. The degree units are going to cancel and we're going to be left with radians. Notice I'm not actually writing radians here. What indicates that it's radians is the pi that's actually there. That's what's telling us that we have units in radians. So 30 over 180 would reduce to 1 over 6. So I'm just going to write that as pi over 6. Okay, negative really doesn't make a difference here. I'm still going to multiply by pi over 180. Okay, and I'm going to reduce. So that's going to reduce to negative 11 ninths. So negative 11 pi over 9. So not too bad. So let's look at the other way here. If we have radians, and remember I know that I have radians on this bottom row because there's pi, we're going to multiply by 180 over pi. And the way I remember that is I want the pi's to cancel out. So if I have a pi up top and a pi on bottom, they're going to cancel. And then I really just have some simplifying to do here. 4 times 180 and then divide by 3 is going to give me 240 degrees. Okay, same thing over here. I'm going to multiply by 180 over pi. Pi's are going to cancel. I'm going to do negative 5 times 180 and then divide by 36 to get negative 25 degrees. So hopefully you're getting the hang of this. It's really just dimensional analysis, same as you might do in science. Pi's cancel, and I simplify to get 315 degrees. Okay, so radians are just a different unit of measurement. Let's talk about some special type of angles now. So we have something called coterminal angles, and these are angles in standard position that have the same terminal side. Now, what that means is the angle you see on the screen could be, let's say, a 60-degree angle. But maybe it goes around one full time first before reaching this. Okay, that could also then be a 420-degree angle. Or maybe instead of going counterclockwise, we went clockwise. So maybe this is really a negative 300-degree angle. The point is, we can't really tell just by looking at the angle itself. The 420, the negative 300, and the 60-degree angles are what we would call coterminal angles, because the angles in standard position have the same terminal side. So we call them coterminal angles. Now, a lot of times we're going to be looking for a positive and a negative coterminal angle for a specific given angle. So for something like this, I would start off by sketching the angle that I'm actually given. So in this case, 65, so very similar to the one we just did. So let's call this our 65 degree angle. Now, to get a positive coterminal angle, I could just go around one full time counterclockwise and then go 65 degrees more to arrive at that same terminal side. So to draw a picture of it, that would mean going all the way around and stopping. Well, that's really just doing 360 degrees plus my coterminal, or no, I'm sorry, not my coterminal, but my original angle. If I wanted to get a negative one, that just means I go clockwise this time. So I would start here and I would loop this way, which is really just the same as doing 360 taken away from our original angle. Okay, it's like if we went all the way around, we would have 360 degrees, but we know that we're stopping 65 degrees short of the actual x-axis here. So since we need a negative coterminal angle, we'll do our original angle minus 360. So if you follow this general rule, you'll be able to get the positive and negative coterminal angles without even sketching this. Okay, to get your positive coterminal angle, you typically just do the 360 plus your original. So that would give us 425 degrees. And then usually to get your negative coterminal angle, you just take your original and subtract 360 degrees. So what would that give us here? That would give us negative 295 degrees. Now here's when that doesn't work. It doesn't work when your original angle is bigger than 360 degrees. Okay, 540 degrees means that I started here. Okay, there's my terminal side, or my initial side. I go all the way around once. That's my 360. And then I go another 180 degrees. So then my terminal side is really on the negative x-axis. So looking at this, one way to write this would really just be to say, hey, that's really just 180 degrees. Or if we went clockwise, it's really negative 180 degrees. So this time, just adding 360 and subtracting 360 doesn't really give us what we want. Because if I subtract 360 from 540, I get positive 180. Okay. Over on the left here, subtracting gave us a negative. So to get my negative coterminal angle, I would have to subtract 360 twice because we're kind of like unraveling this, kind of unwrapping it around the coordinate plane here. So sketching helps. If you want to just add 360, subtract 360 until you get what you need, that's fine too. So the other special kind of angle that we're going to be using a lot is called a reference angle. Now, if we have an angle theta, okay, this symbol, if you don't know from geometry, is theta. It's a Greek letter. Okay, for an angle theta in standard form, the reference angle is positive, acute, meaning less than 90 degrees, and it's formed by the terminal side and the x-axis. So this shaded in area here that you see is what we call the reference angle. Now, it's very important that you make sure that your reference angle is always positive and acute. If it's not both of those things, then you're doing something wrong. So let's find some of these here. Okay, so we're going to sketch the angles and then find the reference angles. Okay, so 225 is going to be down here somewhere. Okay, so that would be 225 degrees. Now, my reference angle is the measure back to the nearest x-axis, which will be right here. So we're trying to figure out what that little sliver is. Now, we know that this is 180 degrees here. We went all the way out to 225 degrees, so that must mean that that reference angle is 45 degrees. Okay, it's just the distance from the terminal side back to the x-axis, the nearest x-axis. Notice I'm not measuring from here to here because that would give me an obtuse angle, and I need it to be positive and acute. So let's do a negative one here. Okay, negative 310 degrees means I am coming all the way over about here. Okay, and we went clockwise that time because it was negative. So my reference angle, remember, should always be positive. So we're measuring the distance from that terminal side back to the x-axis. Well, we went 310 degrees clockwise. To get back to the x-axis, we would have had to have gone 50 more degrees. Now, even though our original angle was negative, a reference angle is always positive, so our reference angle is a positive 50 degrees here. Now, let's say we have one that's in radians. Okay, let's just convert this to degrees. Because it's going to make graphing or sketching the angle much easier. So if we do our little conversion here, we find that this is really 120 degrees. So now we can sketch it much easier. 120 degrees is going to put us right about here. Okay, so our reference angle, we're measuring from our terminal side to the x-axis. So to get down to the x-axis there, we would have to go 60 more degrees. And there you go. So sketching is very helpful here. You're just thinking about how far do you have to go to get to that x-axis. And remember, it has to be a positive angle and it has to be acute. If it's not, then you're doing something wrong. So let's talk about how we can relate this new information back to our trig functions. Now, if we have an angle theta, again, okay, and it's in standard form, and a point P, okay, that you can see here, this would be our, let me pick a different color. This would be our point P. It has an x and a y value. The distance from the origin to that point P can be found using the Pythagorean theorem. Now, it's going to be a slight variation. It's not going to be a squared plus b squared equals c squared, because notice that with this diagram over here, if we have angle theta, and this is our terminal side, and point P is on the terminal side, the x value of that point is going to make up this bottom leg of the triangle, and the y value is going to make this leg of the triangle. So r is serving as the distance from the origin to point P, but really we have a right triangle here, so it's really just x squared plus y squared equals r squared. Okay, and that means that r must be equal to the square root of x squared plus y squared. So we can calculate that distance pretty easily, and this is going to lead something called the unit circle. It's something that we'll see in Algebra 2. You'll use it in pre-calc a good bit, and it all deals with this idea of points forming around the edge of a circle that's made up of all of these different angle thetas, and all of these points rest on the terminal sides of those given angles. It's nothing you've seen before, but this is something that's going to be very useful. This idea is going to be very useful when we get to that section of trigonometry. So for right now, let's just work out an example here. Okay, let's say we have a point 5, negative 2, and it's on the terminal side of theta. So we know that theta would have an initial side over here. Okay, we don't know the measurement of theta, but we know that the terminal side has point P on it, and point P has a positive x value and a negative y value. So the point must be somewhere down in quadrant 4. Now, I'm just going to roughly sketch it. Okay, let's call this point P. So that means that the terminal side is here. So we're going to call this point P. This is the point 5, -2. So that must mean, if we draw a right triangle here, that the x distance from the origin to that altitude made by point P would be 5, and then this vertical distance would be -2. We're trying to find the distance from the origin to point P, and then we want to find the exact values of the trig functions of theta. Now, we don't know the angle for theta, but we will have all of the sides. We'll have the opposite side, we'll have the adjacent side, and we'll have the hypotenuse. So we'll have everything we need from this construction here to be able to find the values of those trig functions. First, we just need to find r. So we said that r could be found by x squared plus y squared, and then taking the square root of that. Now, if we do that, we're going to get the square root of 29. And we're just going to leave it as the square root of 29. So let's do our trig functions here. Okay, if I wanted to find sine of theta, we're doing opposite over hypotenuse. Well, my opposite side is -2. My hypotenuse is radical 29. I need to rationalize, though. So I get -2 radical 29 over 29. Okay, to find cosine, I'm doing my adjacent side over the hypotenuse, so 5 over radical 29, and then I need to rationalize again. So we get 5 radical 29 over 29. To find tangent of theta, we're doing opposite over adjacent, so -2/5. Okay, no reducing there. And then we have all of our reciprocal functions. So cosecant. Cosecant is the reciprocal of sine. Now, I rationalized to get my sine answer here, but it might be better to go to this answer before we rationalize. And if we take the reciprocal of that, there's going to be no rationalizing and simplifying that we need to do. So that would just give me radical 29 over 2. Okay, secant is the reciprocal of cosine, and I'm going to do the same thing I did for sine here, where I'm going to look back at cosine before I rationalized, and that's what I'm going to take the reciprocal of. So that's going to give me radical 29 over 5. And then cotangent is the reciprocal of tangent, which is going to give us -5/2. So just with this very little information, knowing a single point, we were able to create this right triangle, come up with all of its sides, and then find all of the trig functions, the exact values of those trig functions for the angle formed by the point on that terminal side. So I know it's kind of odd, but it's all leading to this unit circle that we'll get to later. Okay, it's very complicated, it's kind of weird, but it is something you use quite a bit. So let me know if you guys have any questions, reach out if you're having issues, and have a great day.